Welcome to The Explainer. Today, we're tearing down a complete GCSE physics question, showing you exactly how to get every single mark. And we're tackling a true classic, the skydiver.
Okay, let's get right into it. This distance time graph here, well, it tells the whole story of a skydiver's fall, and it's the key to unlocking a bunch of questions. We're going to walk through a real exam problem, step by step, using the official mark scheme to see what an examiner is actually looking for.
So here's our game plan. We'll start with the challenge itself, then move on to completing a diagram, explaining the motion, calculating some speed, tackling a high-altitude jump scenario, and finally, we'll decode the mark scheme to pull out those winning strategies.
First up, the Skydiver's Challenge. Let's get our heads around the basic setup for question 8.
The whole setup is pretty straightforward. A skydiver jumps from 4,000 meters up. We're zeroing in on just the first 12 seconds of that fall, which is what the graph shows. This is your classic physics problem, testing everything from forces and motion to how well you can read a graph.
All right, let's move on to the first actual question, completing the diagram. This is question 8.1, and it's all about visualizing the forces involved.
Okay, so what are we looking at here? We've got this free body diagram. It already shows one upward arrow for air resistance, specifically at 3 seconds into the fall. The job is to complete it, and it's worth 2 marks. So what's the other big force acting here? And, more importantly, how do we draw it to get those marks?
So, this is exactly what the mark scheme is looking for to give you full credit. First, you got to draw a downward arrow starting right from that center dot. That's 1 mark, nice and easy. For the second mark, you have to label it. Either weight or gravity will do. And here's the absolute kicker. Your downward arrow must be visibly longer than the upward air resistance arrow. That shows the examiner you get it. The skydiver is still accelerating downwards at this point.
All right, now for the big one, the 4-mark explanation question. This is where you really get to show what you know by telling a logical story with the right physics terms.
The question wants us to explain the changing motion, and we have to do it by talking about the forces. The key words there are changing motion and forces. You've got to connect them. It's all about connecting the dots. Why is the skydiver's speed doing what it's doing on that graph?
Let's tell the story of the fall bit by bit, just like the mark scheme wants. So, right at the start, the instant they jump, the skydiver's weight is a huge downward force, way bigger than the tiny bit of air resistance. That creates a large overall or resultant force downwards, and boom, they accelerate.
But then what happens? Well, as they get faster, the air pushing back on them, that's the air resistance, gets stronger and stronger. This is the crucial part. That growing upward force starts to cancel out some of the downward weight. This reduces the resultant force. So they're still speeding up, yeah? But just not as quickly as before. And then we get to the grand finale, terminal velocity. Eventually, they're falling so fast that the upward force of air resistance grows to be exactly equal to their downward weight. It's a perfect balance. And when the forces are balanced, the resultant force is 0. No more resultant force means no more acceleration. They're just falling at one constant, super fast speed.
So there it is, the perfect 4-mark answer, laid out step by step. You see that logical chain? You state the forces are imbalanced, link that to acceleration, explain how the forces change as speed increases, and then describe the final balanced state. That is the exact story that gets you all 4 marks.
Next up, a little bit of math. We're going to calculate the speed, and this is all about pulling the right numbers straight from that graph.
Okay, the question asks for the speed between 7 and 12 seconds. Now, if you look really closely at the graph in that zone, what do you see? The line is perfectly straight, and a straight line on a distance-time graph means only one thing: constant speed. That's our big clue. The skydiver has hit terminal velocity.
Okay, let's see how we can scoop up all 3 marks here. First, let's just grab the numbers off the graph. So, at 12 seconds, they're at 400 meters, and at 7 seconds, they're at 200 meters. Just showing this subtraction, 400 minus 200 gets you a mark. Easy, right? For the next mark, you just plug those numbers into the speed equation. The distance covered is 200 meters, and the time taken is 5 seconds. So you write down speed equals 200 divided by 5.
And when you do the math, bam! You get your final answer, which is worth the 3rd mark, 40 meters per second. Always remember to include those units.
All right, let's tackle the last part of the question, 8.4. This one's a bit of a curveball. It's about a high-altitude jump, so we've got to apply what we know to a totally new, more extreme situation.
So the question is, why would jumping from way, way higher, like 39,000 meters, let a skydiver go so much faster than jumping from 4,000 meters? What's the big difference up there? Let's figure it out for 3 marks.
It all comes down to a 3-step chain of thought, and this is straight from the mark scheme. Step 1. At that insane height, the air is so much thinner, right? The atmosphere is less dense. Just saying that gets you a mark. Okay, so what? Well, step 2. If the air is thinner, there's less stuff to push against you as you fall. That means less air resistance for any given speed. And for the final point, and this is the clincher, if there's less air resistance fighting against your weight, you get to accelerate for way, way longer before those forces finally balance out. And a longer acceleration means, you guessed it, a much, much higher top speed. So we've completely picked apart this question. What have we actually learned? What are the big strategies you can walk away with to nail your exam?
It really boils down to a few key things. First, use the right language. Don't just say gravity, say weight. Don't just say force, say resultant force. It matters. Next, when they ask you to explain, tell a story, a logical sequence of cause and effect. For the math parts, you have to show your work, every step. And finally, when you're comparing two things, just ask yourself, what's the one key difference? In our case, it was air density. See, it's not just about knowing the physics, it's about showing the examiner you know it in exactly the way they want to see it. And there you have it, our deconstruction of this skydiver problem. The big question I want to leave you with is this. How are you going to use this kind of structured, mark scheme-focused thinking on the next problem you tackle? Because really, learning to think like an examiner, that's half the battle.